are the dream teams, and we're going to talk about the voting machine mechanism in this video. An electronic voting machine is being used by a community to select proposals. Every voter has the option to cast a binary vote. A vote in support of the proposal is represented by a 1, and a vote against the proposal is represented by 0. The following rules should be used by the voting machine to determine the proposal's outcome. If majority votes support the proposal, it is adopted. If not, the proposal is turned down. Voting machines were created to address various challenges and improve the electoral process as it was more efficient. Voting machine also helps to reduce human errors in counting and can prevent fraud from happening. Hence, it will ease the selection of proposal in community. The block diagram shows where ABC is the voters, which are the inputs, while X is for approve and Y is for against, which are the outputs. The truth table shows the relationship between input and output. If all voters vote 0, which is against, the Y will light up as the majority is against the idea.
To express the equation from the truth table, we decided to use K-maps to obtain the output expression. For output X, that majority is approved, we get F equal to AB plus BC plus AC. For output Y, that majority is against, we get F equal to A bar, B bar plus B bar C bar plus A bar C bar. For the logic circuit of basic logic gate, we use Intel Quarter software to design and draw our logic gate. First, our circuit consists of 3 inputs A, B, and C. We use 6 AND gates, 3 inverters, and 2 OR gates to designing our logic circuit. The upper part is describing the output X, while the lower part is describing the output Y. Next is the logic circuit of NAND logic gate. We use the same software to design this circuit. This circuit also consists of 3 inputs A, B, and C. We use 26 NAND gates. We can see the rule of convert basic gate to NAND gate from our lecture's notes. The upper part describing the output X, while the lower part describing the output Y. In the same software, we create its waveform. For the waveform of NAND logic circuit is same with basic logic circuit because the output of the two logic circuit is same.
Comparison between basic logic gate and NAND gates. The first factor is gate count. For basic logic gate is lower. Each gate, AND or NOT, does one job, so fewer gates are needed. X have 4 gates while Y have 7 gates. For NAND gates have higher. NAND gates need to be combined to perform basic functions, so more gates are required. X have 9 gates while Y have 12 gates. The next factor is design complexity. For basic logic gate is simpler. Directly use AND, OR, and NOT gates, making the design process easy to follow. For NAND gates is more complex. Need to be combined NAND gates to create AND, OR, and NOT function. Next factor is hardware cost. For basic logic gates is higher. It requires different type of gates, leading to more components for ICS. For NAND gate is lower. Only one type of gate, NAND gate, is needed, reducing the number of components. This last factor is power consumption. For basic logic gate is higher. Power use increase with more gates, especially for AND gates, while NAND gate is lower. NAND gates are generally more power efficient, and even if there are more gates in total. The conclusion: basic logic gate offer simplicity in design, making them easier to work with, especially for smaller, less complex circuit. They reduce design complexity, lower the gate count for small systems, and offer straightforward implementation. However, they come at the cost of higher hardware complexity and power consumption, as they require more components and consume more power, particularly in AND gates. For NAND gates, require more gates to replicate the function of AND, OR, and NOT, present significant advantages in terms of hardware cost and power efficient. By using only one type of gate, design can be more cost-effective and energy efficient, which is ideal for larger or more resource-constrained systems. However, the design process becomes more complex due to the need to combine multiple NAND gates to form basic logic function.